Hello and welcome to the electricity unit for Physics First here at GCA. And the first thing I'm going to show you has to do with this plate of money. And I don't know, what is this, $100, $1,000? I don't know. Anyway, shredded money on the plate. And I also have a water balloon. So what kind of electricity am I creating? And hopefully you said static electricity. It gives things opposite charges, and then they're attracted because opposites attract. And so the balloon is always negative. But friction is not the only way to make a static charge. I can put the balloon a little closer, near the money, and look at that, they get statically charged. And then they jump up to the balloon. So they get their original static charge through something called induction, where there's space in between. And then once they jump up to the balloon, you can see some of them shoot back off the balloon. That one just went over to the candle. That is a third way of charging the balloon, through conduction, where it's actually touching. So we'll learn more about those in 3 weeks, but first we're going to do our current electricity unit. And let me just make this more interesting. Okay, so I have here a book with a couple of batteries. These are D batteries. They are 1.5 volts each, and that's kind of tells you how much energy they have. Same voltage as any other standard battery, like a C or a AA or AAA. And then I also put my plate of paper away. I have a couple of candles, because you're probably thinking, what do candles have to do with electricity? They don't have anything to do with electricity, but they can tell you the direction that the fan is blowing the air. Is it blowing the air forward? Or is it blowing the air backwards? That one will light up. So, see if I can get everything in the video here. So I have one battery. I'm going to connect my leads to make a full, complete loop. This loop is called a circuit. So I'm going to touch those, one to the positive end and one to the negative end of the battery. And you can see that the air blows forward. That candle is looping. But what if I switch the leads, put them on the other way? Now the electricity is flowing backwards through the circuit. And you can see it blowing the light bulb behind. It's still not lined up very well. It's just not meant to go backwards, is it? But you can see it moving there. Okay, so forwards, backwards. Pretty cool. So let's predict now. What do you think will happen if I add a second battery? And if you need more time to predict, go ahead and pause it. And here, let's see what happens with two batteries. I've now doubled the voltage. You might be able to hear it. That it's going around much more quickly. And look at that. It was enough power, enough current flowing through here to blow out that candle. And I'm just going to show you one more thing. Aha, here it is. I can add a light bulb into the circuit, and notice that's still one path. This is a series circuit, and look at that, the light bulb lights. What's happened to the speed of the fan? Let's see if you can hear and see a difference. And maybe it would help too. I don't know if you can hear that, so I'll put this over here. Okay, with the light bulb, and without the light bulb. Oh, there we go, it blew it out. Okay, so when you add more devices into the path, they have to share the voltage from the battery. Since they're sharing it, they each get less voltage, so they have less current, so it goes more slowly. And that is my introduction to electricity. I hope you enjoyed this unit. It's one of my favorites.